Okay, Bismillah ar-Rahman ar-Rahim. Dear students, we have read about the sequential circuits, and today we talk about the combinational circuit. And in the combinational circuit, we start with the SR latch, and then we add up a clock to the SR latch to make it a flip-flop. So first, let us try to understand what is the difference between the sequential circuit and a combinational circuit. जो अभी तक हमने किए वो सारे कॉम्बिनेशनल सर्किट थे, क्योंकि उसमें दो चीज़ें नहीं थी जो हम अब ऐड करेंगे. वन इज़ द टाइम एंड अदर थिंग इज़ द स्टेट. ओके, द स्टेट एंड टाइम. Basically it's gone out of the screen, so I will write it here. So we will add the state and time to it. यानी कि जो हमारा सर्किट था, इससे पहले जो भी सर्किट था उसमें आपके इनपुट्स आ रहे थे, and these inputs will go to one or more outputs. Okay, we could have many outputs, but the state was not stored. That means कि जो output आए उनको कोई दखल नहीं था कि वो input के साथ फिर करके कुछ next time वो कुछ बनाए. यानी कि next input जो हमारे input है, they are the function of the present input, और जो output आया वो स्टोर नहीं हुआ था. जैसे कि आपको BCD नंबर है एंड यू वांट टू कन्वर्ट इट इनटू द बाइनरी. सो BCD नंबर्स आ रहे थे, बाइनरी बन रहे थे, लेकिन जो बाइनरी बने उनके बिना पे आपका नया बाइनरी नहीं बन रहा. इनपुट्स कम, दे गो इनटू द आउटपुट. लेकिन अगर अब आप इसी कॉम्बिनेशनल सर्किट को एक मेमोरी यूनिट लगा दें एंड जो आउटपुट्स आ रहे हैं उस आउटपुट्स को आप स्टोर कर रहे हो यहाँ पे, और इस आउटपुट के बिना पे जो इनपुट्स है, जो नेक्स्ट इनपुट है, दैट इज़ द जो कि आउटपुट आया था इससे पहले, दैट हैज़ गॉन बैक टू द इनपुट. एंड जो अब जो आउटपुट है वो इस पे नहीं ओनली डिपेंड है कि क्या इनपुट्स हैं, बल्कि ऑल्सो नो द प्रीवियस आउटपुट क्या था. For example, you have a counter. काउंटर में आप कह रहे हो कि प्लस प्लस करोगे आप नेक्स्ट काउंटर में, से फॉर एग्जांपल 4 है, ठीक है ना. सो नेक्स्ट टाइम जब आप इसको प्लस प्लस करोगे, इट इज़ नॉट द इनपुट ओनली, इट इज़ ऑल्सो द जो आउटपुट आया था 4, क्योंकि आप 4 को इनपुट कर रहे हो 1. सो द काउंटर इज ए सर्किट हियर एंड देयर इज सम स्टोरेज जिसमें इसमें हुआ था स्टोर 4. नाउ जो यहाँ प्लस प्लस आप कर रहे हो, यहाँ से इनपुट आ रहा है ये 4, और इसको आप प्लस करके अब 5 बना रहे हो, एंड सो ऑन. सो द काउंटर इज नॉट डिपेंडेंट ओनली ऑन द इनपुट बट ऑल्सो ऑन द प्रीवियस आउटपुट. सो हियर इन अ sequential circuit, the present input and the previous output makes the current output. So current output is a function of not only the current inputs but also the previous output, क्योंकि ये वापस जाता है. तो सीक्वेंशियल सर्किट में ये दो चीज़ें, एक चीज़ तो ये होगी स्टेट, और दूसरा चीज़ टाइम, यानी कि सिंक्रोनस. हम कॉम्बिनेशनल सर्किट में कभी भी इनपुट्स को हम आउटपुट में कन्वर्ट करते थे, लेकिन इन द सीक्वेंशियल सर्किट देयर इज अ कंसेप्ट ऑफ क्लॉक, दैट वी वर्क ओनली ऑन द एजेस ऑफ द क्लॉक. We do not work randomly. So that's also called the synchronous circuits. तो उसके बाद हम पढ़ेंगे what is the difference between synchronous and asynchronous circuits, वो उसके बाद होगा. तो ये एक जनरल सी डेफिनेशन थी, what is the difference between a sequential circuit and a combinational circuit. So जो मेरा ये sequential circuit है, it is the only the combinational circuit, वही combinational circuit है, लेकिन अब इसको हमने मेमोरी यूनिट देके जो आउटपुट था वो वापस इनपुट में जाके नए आउटपुट्स निकाल रहा है, ठीक है ना. तो जो इसके पहले कॉम्बिनेशन सर्किट जैसे एडर हमने पढ़े, मल्टीप्लायर, सब्ट्रैक्टर, उनमें ये चीज़ नहीं थी, उनमें इनपुट्स आ रहे थे, आउटपुट जा रहे थे. लेकिन इसमें कॉम्बिनेशनल सर्किट्स में, सीक्वेंशियल सर्किट्स में दो चीज़ हम ऐड करेंगे, एक तो स्टेट और दूसरा क्लॉक, ठीक है. तो जो ये स्टोरेज यूनिट है, अब इसके ऊपर अगर हम काम करेंगे, जो स्टोरेज है, क्योंकि सीक्वेंशियल सर्किट्स वर्क्स इन अ स्टोरेज, ठीक है ना. तो स्टोरेज को हम कैसे करेंगे, हम कैसे स्टोर करेंगे चीज़ों को, उसके लिए हमारे पास दो चीज़ें हैं. एक को हम बोलते हैं लैच और एक को हम बोलते हैं फ्लिप फ्लॉप, लैच एंड फ्लिप फ्लॉप, ठीक है ना। जो बेसिक लैच है, फ्लिप फ्लॉप दरअसल लैच के ही बने होते हैं, लेकिन अगर हम इनको क्लॉक डालेंगे तो ये फ्लिप फ्लॉप बनेंगे। तो बेसिक स्टोरेज जो हमारी है दैट इज नथिंग बट द लैच। नाउ इफ वी ऐड टू इट द क्लॉक इट बिकम्स अ फ्लिप फ्लॉप। नाउ लेट अस ट्राई टू सी द डिफरेंस बिटवीन द लैच एंड फ्लिप फ्लॉप। तो अब हमारा टॉपिक ही रहेगा, लेकिन फिलहाल हम इस बात के ऊपर काम करेंगे व्हाट इज अ लैच और लैच को हम बनाएं कैसे, ठीक है। सो जो बेसिक हमारी लैच है, so it is also called as SR latch. Oh, I'm writing out of screen, so I should write little down. So it is जो basic हमारा जो है that's called as an SR latch. So why we call it latch? Because it latches. When you latch something, it's still going out of the screen. Let me write it a little down. So that means my screen is only this much. I don't know why I have set the camera wrong way. Anyways, so I have the basic SR latch. So why we call it a latch? Because it latches to the bits and stores that. Okay? And जो ये SR latch है, हम इसको या तो NOR से implement कर सकते हैं या NAND से। और अगर इसी लैच को मैंने क्लॉक दे दिया तो ये मेरा बनेगा फ्लिप फ्लॉप। दैट विल बी आवर नेक्स्ट टॉपिक। ओके, वी विल रीड all of this in class, but this is a pre-class video to make you ready for the class. ठीक है ना? So that you will not have any issues in the class. So you are upfront having all the knowledge before going to the class, all what is required. So now I want to create SR latch using the NOR. So first of all, let us see what is NOR. So we know already the NOR gate, that is the invert of the OR, that you put up the inverter to the OR, flip the OR to become the NOR. Or you can say that अगर आपने नॉट गेट लगाया और के साथ तो ये आपका नॉर बनेगा। वो तो सिंपल ही है। यानी कि अगर मेरे पास A और B दो इनपुट्स हैं, फर्ज कीजिए 0 0 0 1 1 0 1 1, ठीक है, और मैं इनको नॉर करता हूँ। आई वॉन्ट टू A और B complement, that's the NOR. So what will be my output? Let us see it. So और मुझे पता है कि अगर एक भी 1 होगा तो आउटपुट विल बी 1, तो NOR उसका उल्टा होगा। यानी कि अगर 1 कहीं पर भी है तो आउटपुट इज गोइंग टू बी 0, बिकॉज और का उल्टा है। ये मीन्स अगर कहीं पर भी 1 था तो और हमें 1 देता, लेकिन NOR उसको 0 देगा, और NOR आपका सिर्फ 0 0 जब दोनों होंगे तो 1 देगा। So the dialogue I remember here is that if I have one of the inputs 1, output is gonna be the 0. We have to understand that. I have to use this thing. That wherever I see the 1, if one of the inputs is 1, I don't want to see the other input. Look, if one of the inputs is 1, the other input is 0 this time. If one of the inputs is 1, other input is 0 this time. If one of the input is 1, other input is 1 this time. So it is immaterial what the other input is. I don't want to think about that, because if one of the inputs is 1, output has to be 0. ये याद रखना है नॉर के गेट में कि अगर एक इन दोनों में से एक इनपुट 1 आया तो आउटपुट गारंटीड 0 है, और नॉर गेट में सिर्फ 1 आउटपुट तब आता है जब दोनों 0 होंगे। ठीक है, नाउ आई विल यूज इट टू बिल्ड माय SR latch. Okay, let me call this as an R and let me call it here S as my inputs, and I am using two NOR gates. So this is my one of the NOR gate and this is my another NOR gate. Okay, it is its output, it is called Q, and it is called Q complement. That means output always has to be complement of each other. If it is 1, it will be 0. If it is 0, it will be 1, because if it is Q, it is Q complement. Now because this is sequential circuit, so there will be R going like this, S may be going like this, okay, but there has to be some feedback loop. If at all this has to be some kind of a sequential circuit, then we have to have the feedback loop. Okay, the feedback loop with this is the output of this go to the input of this, it's coming back. The output of this NOR gate is coming back to this NOR gate input, and maybe I use a different pen. The output of this is again the same pen, here is the blue pen. The output of this NOR gate, okay, is going to be the input of this NOR gate. Now see, now what I am technically saying is this is a SR latch. S means set. Why we say it S? Because S means set and R means reset. Okay, so I call it a set as a set and reset circuit, and this is a basic SR latch. And if you understood the SR latch, you will understand whole of the sequential circuits, the flip flop, the D flip flops, the T flip flops, JK flip flops. Everything will be easy if you understand this is the basics of it. That's why I'm making a separate video for this, for you guys, so that you understand it properly. Now understand carefully what I'm saying. That I know the dialog here from the NOR gate, because the NOR's behavior is this, that if one of the inputs is 1, immaterial what the other input is, output is gonna be 0. Only output will be 1 when both of the inputs are 0, 0. Does it make sense? Okay. Now, question, that if I have this scenario of a circuit that where I have 2 NOR gates, and output of this NOR gate is the second input of this gate, and output of this NOR gate is the second input of this gate. ठीक है ना? So because we are on a sequential circuit where output comes back to the input, here it goes. But our motto is, and our assumption is, that this circuit is going to store my data. So I can use it as my RAM. I can use it in a storage unit, because it latches the bits, means it stores the bits, latch it. Like we have the latch in a door, so which stores the things and so on. It's like that. It's like here. It latches it. It latches the, whatever the input is, it latches it, it stores it there, and we will see how it stores it there. And because we use this as our memory unit. Now basic dialog is this, and we work it out with this. So we will have some cases, okay? Let's put up some cases here. So let me call it as a case 1. In my case 1, what I am saying is that I have, say for example, R0. So let this is R and this is S, okay? R is my 0 and S is my 1. Let it be like that. Let's start with this. R is 0, S is 1. So that means if I write here, R is my 0, let me write here smaller, R is 0, S is 1. The dialog with the NOR gate is, if one of the inputs is 1, output is gonna be 0. So I will start with this one, because now whatever the input, other input is, I don't care, because NOR gate's behavior is, if one of the inputs is 1, what is the other input, I don't care, its output is 100% going to be 0. So Q complement is going to be 0. So if I write here Q and Q complement to this table here, okay, and I get for 100% guarantee that Q complement has to be 0, because if one of the inputs is 1, output is gonna be 0, because I know the NOR's behavior here, right? Now if this output is 0, this output goes to the second input of this NOR gate. One of the inputs is 0, okay, one of the inputs is 0, and now the second input is also 0, because in this case I said one of the input is 1, output is 0. Now this 0 go back to the input of this NOR gate, और 0 क्या बनाएगा? 0 0 बनाएगा 1. So guaranteed it will be 1. So that is why we say if it is Q complement, it is Q. So if it is 0, it's gonna be 1. If it is 1, it's gonna be 0. आपस में complement है. So that means Q will be 1. Now when Q is 1 and Q complement is 0, because we started with 0 1, okay, because 1 means set, as you could see here, 1 means set. So it is the set, because I am having Q1. If Q is 1, that means set. So the output of this is set. I can say it is a set circuit. Now comes the memory part. Now output has happened to be 1 0, Q is 1 and Q complement is 0, मतलब ये set हो गया, ये circuit हमारा set हो गया, ठीक है? लेकिन अब ये याद रखना चाहिए, जो ये आउटपुट इसका है, इट शुड रिमेंबर दिस. नाउ हाउ इट विल रिमेंबर, हाउ वी चेक इट, हम इनपुट्स हटाएंगे. अब ये 0 1 जो है ये हटाएंगे. हम क्या करेंगे काम, इसको 0 0 रखेंगे यहाँ पे. ठीक है, वी विल कीप इट 0 0 एंड वी बिलीव दैट इट स्टोर्स दिस 1 0. इवन दो आउट इनपुट्स हमने हटा दिए, वी रिमूव द इनपुट्स, स्टिल आउटपुट हैज टू बी 1 0. So let us check it out. So we will work, because our NOR dialog is, if one of the inputs is 1, output is 0. So we start with this 1 and it is coming here input as 1. So 1 and 0. So whatever it is, I don't care, because one of the inputs is 1, output has to be 0. So it stays as 0. Now this 0 goes to the second input of this NOR gate, and 0 and 0, 0 0 is 1. So it stays at 1. So that means if it was 1 0, and I did what in the case second, in my case second, I will not say case second, rather I will say the memory, it's called the memory state, that I put up here 0 0. I put up here 0 0. So if I put up 0 0, the outputs will remain same. So what does that mean? That means it's a memory state. So it is a memory state. So 0 0 means memory. Okay, now you should know that if this is 1 0, it will stay as 1 0. If it was 0 1, it will be 0 1. Whatever the previous state is, it will stay like that. Okay, now we move on to the case second. In a case second, what we do is we keep our, okay, this is memory state. Now case second comes up here, where I am doing what? I am keeping R as 1 and S as 0. अब मैं उल्टा कर रहा हूँ. अब मैंने R को 1 कर दिया और S को 0 करना है. तो यानी कि ये मैं हटाऊंगा फिलहाल. Now R is 1 and S is 0. And whatever it is, I don't know, I will have to calculate the outputs. Okay, let me rub it a little bit. Now R is 1, S is 0. Now which gate will you start? Because we know the dialog of the NOR gate. If one of the inputs is 1, output is going to be 0. So use who is 1. Oh, I'm saying R1. S is 0, so I will start from the R. Because I know if this input is 1, immaterial what is coming from this side. Immaterial, whatever it is it 0 or is it 1? क्योंकि दो ही चीज़ें हो सकती हैं, या यहाँ से 0 आ रहा है या 1 आ रहा है. It doesn't matter, because if one of the inputs is 1, output is going to be 0. And now 0 and this 0 comes from here into its input, second input, and his S input is 0 also. So 0 and 0 is what? That is 1. So output will be 1. So that means in this scenario, Q will be 0 and Q complement will be 1. It is going good because Q is 0, so Q complement has to be 1. इसका उल्टा होने वाला है, क्योंकि ये Q अगर है तो इसका complement है, तो अगर ये 0 है तो 1 होगा. So now this time around, my Q is not set, Q complement is, that means it is reset state. So I call it as this is reset state. Okay. Now if you apply the memory state to it again, if you apply 0 0, then you remove these inputs. You call it 0 0, and we believe that this is a latch, this is a storage unit. It will store this, it will latch to this 0 1. It will store whatever the output was. Let us try to see if it is 0 0. Okay, what will happen? We will start from the 1, because this 1 input comes in here. So immaterial whatever it is, output is gonna be same 0. Now this 0 and 0 comes up here, because 0 from here comes here, and this 0, okay, 0 0 is 1. 0 0 is 1. So it keeps the input same. Even though I removed the inputs, output is gonna be the same. So that means if I do it 0 0, it will stay as 0. Whatever the previous state was, it will retain that. So that is again a memory. So 0 0 is memory state. Okay. Now we have the last case, that is 1 1. If we put R1 S1, that is the problem with this latch. 1 1 is a race condition which is not allowed, which has a problems with it. That is why we thought about the other things. We went into the flip-flop, then we went into the D flip-flop, then into the JK flip-flop, and so on and so forth. So, but because this latch has a problem of 1 1, which is not allowed state, and we want to see why is this not allowed state, why we do not allow 1 1 in case of SR latch. Okay, Let's try to think about it. Let's see what will be the 1 1 state. If that means if both are 1 1, if this is 1 and this is 1, I need to little bit of, okay, let me rub it with this because cleaning is an issue here. So if I have got now 1 and 1, both of the inputs are 1 1, and I know what is the dialog. If one of the inputs is 1, a material what is the other guy comes, I don't care, output is gonna be 0. And what about this guy? If one of the inputs is 1, whatever the other input is coming from this side, is it 0 or is it 1? I don't even look at it because I know if one of the inputs is 1, output is gonna be 0. So in this case is this will be also 0, this will be also 0. So if I have a 1 1 state, the q will be also 0, q complement will be also 0. Okay, now if it is both are 0 0, so पहले जो ये q और q complement का concept था वही खत्म हो गया, because अगर ये 0 था तो ये 1 होना चाहिए था, क्योंकि ये q है तो इसका complement है, अगर ये 1 था तो वो 0, लेकिन दोनों 0 आ गए. So that means it is a wrong input output, कि दोनों 0 0 नहीं हो सकते because हमारा q and q complement है. Okay, अच्छा, एक तो पहले इसने ये खराब कर दिया, हमारा q and q complement का मसला खराब कर दिया. और दूसरा मसला इसमें क्या है कि अब अगर मैं 0 0 कर दूंगा इसको, इज दिस कमिंग इन माय स्क्रीन? यस. अगर मैं अब इसको 0 0 करूंगा, मेमोरी स्टेट, मैं देखूंगा क्या ये रिमेंबर करेगा अपना वैल्यू या नहीं, उसमें भी इश्यूज हैं. उसमें इश्यूज ये है कि डिपेंडिंग अपॉन विच गेट इज फास्टर, इट विल गिव 2 आउटपुट्स. इट विल नॉट गिव ओनली 1 आउटपुट, इट गिव्स 2 आउटपुट्स डिपेंडिंग अपॉन विच गेट इज फास्टर, कि किस गेट ने पहले काम किया, क्योंकि दोनों में से तो एक पहले करेगा ही करेगा. ठीक है, क्योंकि कितने ही ये इक्वल गेट्स क्यों ना हो, एक ही कंपनी के बनाए हुए 2 नॉर गेट्स हैं, तब भी स्लाइट फर्क तो होगी. इट इज नॉट पॉसिबल टू मेक 100% सेम. कुछ ना कुछ थोड़ी सी हल्की सी फर्क रहती है. सो दैट मीन्स कि सटल डिफरेंस विल बी इन बिटवीन द टू, एंड कभी एक गेट कैच कर पाएगा, एक पहले निकलेगा दूसरा बाद में करेगा, तो इस सूरत में वो होगा, इसमें वो फर्क पड़ेगी. बाकी में फर्क वो नहीं पड़ती, बाकी में चाहे ये गेट निकले वो गेट निकले, आउटपुट हैज टू बी दीज फॉर एवर. वट एवर द आउटपुट इज कमिंग हियर, इट इज गोना स्टे लाइक दैट. लेकिन जब 1 1 स्टेट है, उस सूरत में फास्ट गेट जो दोनों में से होगा वो आउटपुट बनाएगा. ठीक है, तो देखते हैं क्या बनाएगा. मैंने पहले कहा कि अगर दोनों 1 1 है तो दोनों यहाँ पे 0 0 आएंगे, बिकॉज इफ वन ऑफ द इनपुट्स इज 1, आउटपुट इज 0. इफ वन ऑफ द इनपुट्स इज 1, आउटपुट इज 0. अब फर्ज कीजिए मैंने 0 0 कर दिया, यानी कि मैंने इसको हटा दिया. मैंने अब क्या किया काम, मैंने इसको भी 0 कर दिया, इसको भी 0 कर दिया. मेमोरी स्टेट में देखना चाहता हूँ क्या होगा कि अब मैंने इनपुट हटा दिया. तो उस सूरत में क्या होगा कि अगर फर्ज कीजिए ये गेट फास्टर हुआ, ठीक है, तो इसने इस 0 और इस 0 ने मिलके इसका आउटपुट कर दिया. सो व्हाट इज 0 0 1, so यानी कि ये कट होके 1 बनेगा. ठीक है, ठीक है ना, तो ये कट होके क्या बन गया 1. नाउ this 1 and this 0 comes up, 1 comes from here, so output is going to be 0. So it will be 0 1, that means it will be reset. It will be, क्योंकि ये q complement is 1, q is 0, that means it's reset. तो ये reset हो गया आपका. अब फर्ज कीजिए कि ये फास्ट नहीं था, ये फास्ट था, ये वाला गेट फास्ट था, तो इसका 0 यहां से आके 0 0 क्या बनाएगा, ये 1, तो ये 1 बनेगा. और 1 जब इसको मिलेगा 1 0 मीन्स 0, सो यानी कि q1 बनेगा, q कॉम्प्लीमेंट यानी कि ये बनेगा सेट. सो ये सेट बना या रीसेट बना, इट डिपेंड्स ऑन किस गेट ने पहले काम किया. नाउ इन दिस सिनेरियो दिस इज अनरिलायबल. वी विल नॉट tell people whether it will set or it will reset. We don't know, right? So that's the bad thing. We cannot build a circuit which is unreliable, because what we tell them as an engineers that this is working this way, it has to work this way. But here it is unreliable, and we don't know what will be the output, and we also have breaking the concept of q complement. So we are saying, bro, this is not allowed. 1 1 state not allowed. We put the cross there, we say not allowed, don't do that. Okay, don't you ever touch it. So maximum times, you know, people go to some dangerous thing, there is written don't touch it. So this is what we do. And but what happens is if we have a door and we write there, do not look, open this door. First thing which comes in a mind when you go there, now what will come in a mind? The first thing you go to that door, you will really open it, you want to see it. अगर 100 doors होंगे, 100 में आपको एक नहीं लिखा, don't open it. एंड आप टेम्प्ट करोगे नहीं, बिल्कुल मुझे भी खोलना ही है, अब तो ये खोलना ही है, तो देखना इसके अंदर है क्या. ये ह्यूमन साइकोलॉजी है. सो द सेम इज हियर. इफ वी आर टेलिंग पीपल डोंट डू इट, so people will do it, and we're not gonna allow that, right? That's why we're gonna work more so that we do not allow this 1-1 state at all. It never happens, even though people try to it, but we may put up complements there or inverters there to not allow it. Do you understand? But before we do that, we have to use another implementation of using NAND. So we put up the NAND gate, NAND. What is the NAND? It's the not of an AND. This was the NOR, not of an OR, and now the NAND. That will be our next video. That will be again maybe the pre-class video, because I want to jump into the class and discuss it perfectly. Now what you're gonna do is you're gonna watch it, you're gonna put all these things in your brain, okay? Before you land in the class, you will be really prepared, and you will understand everything. But if you do not get these concepts, you may find lost in the class, because our sequential circuits, it needs more efforts from you guys and from me also. So I'm putting my efforts here. This is the night time, I'm making a video for you, so you also put up your efforts, and inshallah ta'ala will be all good. So see you next time. Until then, ma salama.